What's up, y'all? My name is Jason Luttrell, and I wanted to show you through, walk you through this entire draft system that we're doing for an event. Now, this is an event inside. It's like a brand activation for a very famous cosmetics and skincare brand, and then in conjunction with a large retailer marketplace that you see on the street every day. You've probably ordered it today. And so in connection with that, so we want to serve a lot of drinks really quickly, without having too much time to wait, and then they're actually in large cups, or in very large cups, 16-ounce cups. So the math that we think about is that if there's 16-ounce cups, how much is that? If that of that is going to be ice, and then that becomes how much stuff we actually plan to put in the glass. And then if we want to carbonate it, we end up doing big draft rigs like this. And I'll just this video is just going to walk you through the entire process of how we think about these things and how we execute them in the back of, literally the back of a store. I mean, there's no resources here. We were able to bring in a freezer just to store clean ice. But for the most part, this is literally the back of a store. There's power outlets, but and a couple shelves, but very little else. And so the name of the game is to have 4 drinks on draft. 2 of them carbonated, and then they're also serving a matcha. So it's like largely coffee tea. There's no alcohol this time, but 99% of the work that I've ever done has been with alcohol. And so what we do is we batch cocktails and then put them in here. But these are really, really simple drinks, but they're complex from a production standpoint because they have to be fizzy. Now, so for 4 drinks, we are making 2 redundant systems. So this means that 2 systems are exactly the same, one on each side, because the stakes are high. We have one. It's an event. It's a 5-day event, and there's only one chance to get this right. And so we want to make sure that we have a redundant system in case that there's a small leak in one line, or there's a bad post in a keg, or any of that stuff. All these things factor into like the psychology of like when we're doing a high volume event over a long period of time. We want to make sure that we are factoring these things in so that in case something bad happens, which it always does, that we are able to respond to it and react to it so that there's a continuity throughout the event, so we have time to solve the problem. So that's why we have, although there are only 4 drinks being sold, there are 2 redundant systems. So here's the CO2. This is a 50-pound CO2 tank, which would last this entire event for probably 2 weeks at least. But then on the other side here, we have another 50-pound tank just in case. And so the 50-pound gas tank goes into a 4-line gas manifold, and this is 3/16 line. Don't worry, I'm going to make you like a whole shopping list of things to get if you want to do this yourself. But that's a single regulator, and then we also have a dual regulator backup. And there's a whole kit over there, which I'll walk you through separately to show you all the stuff that we bring as a backup, just to make sure that we are able to solve problems quickly. And then the kegs are going into these big trash cans, these 55-gallon trash cans. And it's really important. It's really important, especially with carbonation is concerned. It's really important to keep everything really, really cold. You have to put them at high pressure and cold if you want them to carbonate, and then you also have to agitate them so that the CO2 has to mix with the water. Now, there's fancier systems. There's Fox systems that just learned about actually that will help you agitate inside of the keg so you can get better carbonation. I did not do that. This is a manual process. And then here's all of our math and our tracking, and I'll walk you through this separately. But the carbonation is really kind of a bear because we have to jack it up at really high pressure to entice the carbonation to sink in, to entice the gas to sink into the liquid, and then we have to shake it up so that we're increasing the surface area so that we're getting more bubbles. And then it goes through all the lines, and then the gas releases as soon as it goes out of the tap. And then as soon as it hits the ice, then the gas releases, and that's when this kind of big explosion. But that's what we see as the bubbles. And so we have to be mindful of all that, and we have to make sure that all this stuff is happening only at the end point and at no point in between, because otherwise it's just going to be flat. It's going to be flat soda, and so that's not good. We don't want flat soda. So the gas goes. So the 50-pound gas tank. I'll do it on this side because these are exactly the same. So the 50-pound tank goes into a single regulator, and I have a dual regulator backup. So in case one of these fails, then what I do is I put a dual regulator right here, and then just port the second line of gas all the way to this manifold right here. right? So that's in case that regulator fails. And so I'm able to have a backup system. So in case this one of these goes bad, because this I don't know the quality of these parts. They're relatively cheap. I got them on Amazon, and I don't know if just somebody was having a bad day at quality control that day. But the stakes are really high, because if one of these goes out, then all 4 of these lines goes out. And so we have to make sure that we are factoring that in. So the gas goes through the regulator. And the regulator, this is how we know how much gas is in the tank. It's always going to be plenty. And then this is the dispense pressure. So it's a little bit higher. So overnight, what we do is we jack up the pressure as much as we can, and we're trying to carbonate as much as possible. So this is normal. This is a little bit higher than normal would be, and then we bring it down to dispense pressure, which is going to be down here. So, and notice when you turn this clockwise, counterclockwise, it didn't go down. You have to release the pressure to see what the actual true value is, and then you bring it down. So that's too low, and then you can kind of bring it up to where you want it to be. So that'll be dispense pressure. But right now it's a couple hours to service, so we've got a little while. So I'm going to keep it up as high as it'll go. If you do it too high, then it'll start to kind of burst at the seams a little bit. I can hear it. This is why I really like to show up really early in the morning before anybody gets here, because there's no chatter, there's no people bothering me, but also the air conditioner isn't on, and so I can hear these little leaks and stuff like that. And I'm getting old, so it's harder to hear stuff. So going through it, this is at carbonation pressure right now. I can only get it to about 30, 35, 30, 36, something like that. And then, but you want to get as high as possible. These kegs themselves will take 130 pounds of pressure. And so so the gas goes out at this pressure at 30. Right now it's 30 psi. Into this manifold, and then the manifold is just a divider. It just divides up the thing. Now notice these numbers here. So we'll talk about naming conventions in a little bit, but naming conventions are how we assign the lines to the taps. So there's 8 taps out there. There's bank A, bank B, and then there goes the AC. And so there's bank A, bank C, and then each cocktail is assigned to a specific line. So whenever you see A4, like when the servers, the bartenders, they say that A4 is out, I know exactly what to do. Or there's a problem with A4, I always know that A4 is it. So if it's a gas problem, then I can just turn off the gas, and then isolate that part. So and so that's why we use manifolds. Rather than dividing this at right here, just like so they all had all the same pressure all the time. No, you need to isolate the gas in case there's a problem. So look at, so A3 is really light. I can tell because this has been overnight, and it's it's soupy in the ice, and so it's higher than the rest of them. This is coffee, just cold brew right here, and so I filled it up last night before I left, and so that's why it's all the way at the bottom. But this one's really light, so it's A3. And I know that the A3 is going to be the blueberry cocktail, and so I know that this one's going to have to get filled up. Now here's my backup of blueberry right here. But to isolate, to change this keg, like all I have to do is just take this off, put the gas on the gas, and then the liquid on the liquid. And also another note is if you're working with me, the gas is always going to be on the left, so that way you don't have to look around for the post and find out what's happening, and see what the deal is. So the gas is always going to be on the left hand side, and then the liquid is always going to be on the right hand side. So that's kind of the gas comes out of the manifold, and then it goes into the left side post. And you're gonna with the gas lines, you always want to do the solid colored line, and then with the liquid lines, you want to do the clear colored line, because you want to see what you can tell. Sometimes you can tell what it is by looking at it. So for instance, this is a little bit pink. I know what that is. This is a little bit blue. There's 2 blue drinks, so it's got to be one or the other. And then this is brown, which means it's coffee. So it's easier to tell if you use clear lines for the fluids and then solid lines for the gas. Also, sometimes it's really hard to tell which post belongs to which. But for me, generally speaking, the white post is going to be the gas, and then the black post is going to be the gas, the liquid. But you can always just take it off and put it on, and it should come on pretty snug and have a nice little collar there, and this is good to go. So you'll notice that I've got 1, 2, 3, 3 kegs on draft right here, and then here's the 4th one this one's actually, sorry, 1, 2, 3, and 4. These are the 4 cocktails, and then I have in the middle here, these are backups. These are redundant backups of these individual kegs. And then over here, this is the B bank, and this is these are these 4 cocktails, 1, 2, 3, 4. Sorry, 1, 2, 3, and 4 that have that has the and that's the B cocktail. So these ones, all these ones in the middle here, are meant for backups. And so when something kicks, it gets backed up right here. Now, if it was really busy, then I also have an additional 4 kegs over there that I would have on another thing of ice. But it just ended up not being as busy as we thought it was for this. But you always have backups, and these ones get charged every day for to carbonate, and we shake them up to make sure that that the gas is infusing in there. And so once the gas is coming into the kegs, then it's starting to push out, like that pressure that's creating inside of there is pushing out into the outpost, or the liquid post. Now, and an interesting tool that we use here, let me see if I can just get this real quick, is an interesting tool that we use here is called a carbonation stone. And so to zhuzh it a little bit and get a little bit of more gas in there, we have the post that comes out. So inside of the keg, there's a short post that comes out of the gas side. So it's gonna be like a short little post with a little knobby little thing, like 2 or 3 inches. And then inside of that, then we attach this to that, and then the gas line goes all the way down to the bottom, and then the CO2 comes out through this little metal stone. And so the stone has these tiny little microscopic things, and it just kind of adds a lot more surface area to the CO2, so you're getting a lot more infusion, and it helps a little bit. It's not like a game changer, but it helps a little bit. I write this note to myself all the time because I want to make sure that I'm wearing gloves for this, because the oil in your hands is enough to clog up the pores in this thing. So I always use gloves when I'm wearing this, and also it's just a food safety thing. So just wear gloves when you're doing this kind of stuff. And then so let's see here. So once the gas goes through the inline into the CO2 line, it goes all the way down to the bottom, because it spits CO2 through this carbonation stone, and then the carbonation rises up, the CO2 rises up through the liquid, hopefully getting infused in there, and then the post out, it draws from the bottom of the keg, and then it pulls all the way up. So if you're using heavy ingredients like syrups and dyes and stuff like that, I've never used food dye in my stuff before, but this is a client's cocktail this time, but that stuff always goes to the bottom. So you have to make sure that you're shaking up your kegs before service, and then you want to draw the line your first day of service. Otherwise, you're going to get the gunk that has settled to the bottom, and sometimes that's enough gunk to like clog up your lines. You have to replumb it, and it sucks. So that's kind of just the overview of what the keg systems is for this particular event. Sometimes it depends on where you're at, but we had to drill holes, and these are 1.5 inch holes that go to the draft line. There's no chilling on the way to the draft line, so these, you want to have like a good amount of volume. Like you want to serve these on ice if you possibly can, because the texture is a factor that you're not going to get like world-class cocktails out of these unless you like really do some crazy stuff, which we can do, but it's just more intense. So for this one, none of that stuff is necessary, but these are, we drilled the line through the hole. Again, it's a redundant system, and then everything goes through here and through these draft lines, and then so this is what you're gonna get. So this one is like probably a little syrupy because it's and a little flat because it's been sitting overnight, but that's kind of what you get. All right, more later.